the equivalent resistance of the given circuit. Here we are given circuit and the respective values of resistances are also given. Okay, now first of all, the current enters from the point A and gets divided as shown. In some of the resistances, same current flows, and in some of the resistances, different current flows. Here we see in this 3 ohm and in this 3 ohm resistance, same current is flowing, and the current from point A gets divided 1, 2, 3, 4, 5 along 5 directions. Okay, the current which is going from this 6 ohm and which is going from this 3 ohm and this 3 ohm gets meet at this point. That's why this 3 ohm resistance and this 6 ohm resistance, this 3 ohm are in series, and this 3 combinedly is in parallel with this 6 ohm resistance. Now let's replace them with their equivalent resistances value. Okay, these two resistances are in series. That's why the equivalent resistance become 6 ohm. Okay, 6 ohm. Now I already said you 6 ohm and 6 ohm resistances are in parallel, and the formula for parallel. Okay, in case of two resistances, 1 by R equals to 1 by R1 plus 1 by R2. Okay, 1 by R equals to 1 by R1 R2 by R1 plus R2. That's why equivalent resistance can be written directly as R1 R2 by R1 plus R2. That's why the equivalent resistance between 6 ohm and 6 ohm becomes 6 into 6 by 6 plus 6, that is 12. 6 to the 12, 2 3 the 6. Okay, the equivalent resistance between these two resistances is 3 ohm. Okay, let's replace them by their equivalent value 3 ohm. Okay, 3 ohm. Again, now these 3 ohm and 3 ohm resistances are in series, and their equivalent resistance is 6 ohm. Let's replace them by 6 ohm. 6 ohm. Now again, this 6 ohm, this 6 ohm, and this 6 ohm are in parallel. Okay, the current enters from point A. Some of the current goes to this resistance, and some of the current goes to this resistance. The current is divided here, and the divided current meets at this point. That's why these two resistances are in parallel. Okay, now let's replace them by their equivalent resistance, which is equal to 3 ohm. 3 ohm. Okay. Again, these 3 ohm and 3 ohm resistances are in series. Let's replace them by 6 ohm. 6 ohm. Again, 6 ohm and 6 ohm are in parallel. 3 ohm. Again, these 3 ohm and 3 ohm are in series. 6 ohm. Now, okay, the current enters from this point A and gets divided here and meet at this point. That's why this 6 ohm and this 3 ohm resistances are in parallel. They are in parallel. That's why their equivalent resistance becomes 2 ohm. The equivalent resistance of the given circuit is 2 ohm. Please follow our Facebook page, Physics with Physics, Physics with Physics, for more updates.